Have a look at practice question set number 21 right now, both questions. Number 1 says an object is 2 meters tall and is located 7 meters in front of a concave mirror that has a focal length of 3 meters. We got to pull out our imaginary physics thesaurus here and translate concave mirror into other terms that may be a little bit more useful for us. What's another word that we use for a concave mirror? Right, converging mirror. Now you got to be careful there, because if this was a concave lens, then it would be a diverging lens. We want to always be thinking of it as converging or diverging. A concave mirror is a converging mirror, which is good news for me, because if I do happen to forget to translate this particular one, I'm going to forget to make the focal point a positive value. But by default, it'll end up being a positive value. It's really important that you remember to do that little translation to converging or diverging when you have a convex mirror or when you have a concave lens. Okay, when it's diverging, then you have a negative focal point. All right, we want to find the size and the orientation of the image. Let's write down some givens here. We know that the object is 2 meters tall. We know that the object is located, DO, 7 meters in front of the concave or converging mirror. The focal length, because it's converging, is positive 3.0 meters. Again, if it was diverging or if it was a convex mirror, then we would say that it was a negative focal length. The size, we're going to find HI here. To find HI, I think I'm going to say HI over HO equals negative DI over DO. But we don't know what DI is, so we're going to have to find that some other way, probably by the mirror equation. 1 over F is equal to 1 over DO plus 1 over DI. 1 over 3, positive 3, equals 1 over 7 plus 1 over DI. And we pull out our calculator and do that little trick that I taught you on that. We're going to say 1 over 3 minus 1 over 7. And we're going to flip that over. We get a value here of 5.25. Now, if it was me, one of the options there, A, B, C, or D, would be 5.25. Okay, I didn't write the question. Okay, they choose the options that they choose, but I'm telling you, one of the most common mistakes that people make, not necessarily in this question, but any question, is you calculate something, but you're not quite done, but yet you see that as one of your options. So you just automatically pick it. Okay, we're not done here yet. If you see 5.25 as an option, it's not the answer. We got to finish this off by saying HI over HO, which is 2.0, equals negative 5.25. If it was negative 5.25 for DI, we'd make it negative DI, or negative 5.25, but it's not. Yeah, let's say negative 5.25 divided by 7. We multiply that by 2. And we're going to get negative 1.5. So we're either dealing with C or D. Is it right side up or is it upside down? And how do you know? Yep. Yep. Good. It's upside down because of the negative. The answer is D. All right. Now, next question. There's 2 ways that we could actually solve the next question. It says when a girl is 122 centimeters tall, stands in front of a mirror. We don't know what kind of mirror. Her virtual image in the mirror is upright and 45 centimeters tall. Her virtual image. I don't know that that's going to be important to me, but I'm going to identify that would be a negative DI just in case that ends up being important to me later on. HO is 122. We're going to say DO is 40. We're going to say HI is 54 centimeters, and we're just going to leave that as positive because the image is upright. We want to know what type of mirror it is, and we want to find out where the image is from the mirror. Let's say HI over HO equals negative DI over DO. 54 over 122 equals negative DI over 40. Let's figure this one out. 54 divided by 122. We're going to multiply that by 40. We get 17.7. or it actually is negative 17.7 centimeters, our answer would end up being either A or C. Okay, now how do we know whether it's convex or concave? How do we know whether it's diverging or converging? Two ways. Anybody come up with one of those two ways? Someone's got to have something here. Good. We can find the value of F. 1 over F is equal to 1 over DO plus 1 over DI. Remember, the value of DI, negative or positive, tells us about the image, whether it's real or virtual, but it doesn't tell us about what kind of device we have, lens, mirror, converging, diverging. But as Nick says, if we find the value of F, and we can do that by doing this, then a positive F would mean converging, a negative F would mean diverging, and we'd have our answer. So let's figure this out. Let's say 1 over 40, subtract 1 over 17.7, or you could have added 1 over negative 17.7. Let's flip that over. Negative 32. The negative focal point means it's a diverging mirror or a convex mirror, so my answer is A. Good. What's my other option to figure this out? There are 10 ray diagrams for mirrors that we draw, right? The diverging mirror ray diagrams are all the same. They all produce an image that is virtual, that is smaller, and is upright. Okay, this is what do we got here? This is an image that's 17 high. The object was 122 high. This is an image that is virtual, smaller, and upright. Okay? So this must be a diverging mirror, sorry. If it was a converging mirror, well, a converging mirror has 5 ray diagrams. 3 of them produce an image that's real. 1 of them produces no image. Only 1 of them produces a virtual image, like we have here. And that virtual image in a converging mirror is when the object is really, really close to the mirror, inside the focal length. But that virtual image is larger, upright, and virtual. Okay, this is a smaller image, so the only way to get a smaller virtual upright image, the only way to get those characteristics is to have a diverging mirror. Okay, converging mirror cannot produce a virtual smaller image. It can produce a real smaller image, but not a virtual smaller image. So the answer has to be A, whether you do it mathematically here or whether you do it via ray diagrams, whatever works for you.